So we are going to just go directly into the notes. I'm going to do a few problems with you in the notes, and then Mr. King will do a few problems with you from the homework. And then it'll be just time in class for you to work through not only the combination, but also going back and thinking about the counting principle and the permutations. So if you could just head to your packet. The last two problems that Mr. King did with you yesterday was distinguishing or determining, is it a permutation or is it a combination? And we're going to do 4 more examples. In extra example 3, this is page 10 of your packet. So if you want to find your packet, go to the bottom of page 10. And I just want you to right now read the problem and just put a P or a C next to the problem. P for permutation, because order is important. So think of Mr. King making a batting order for his baseball team. Or a C for combination, because it doesn't matter how we pair things together. There is no importance of me choosing one person first and then a second person. So the team captain problem that we did yesterday, co-captains, it doesn't matter if we choose one first and then the other person second, or go in alphabetical order. So extra example 3, just P or C. Do not calculate it, because I want to make sure you have it correct before we do the calculation. So can you give me a thumbs up when you have decided A through D? Is it a permutation or a combination? All right. Awesome. Good. So, Bill, we'll start with you. Can you read letter A for us, Bill?
For summer reading, you are asked to read 2 books from a list of 6. How many different pairs of books can you choose to read?
Yeah. So summer reading. Luckily, I never had to do summer reading from the English classes that I took. That just seems horrible. But I know Mr. King assigns. Do you assign Mr. Summer reading, Mr. King?
Oh, no.
Do you like to have just regular summer reading that you wouldn't be assigned a book for?
No.
No. No summer reading for you, huh?
No summer reading.
No summer reading. But I believe my husband, I think he gives summer reading. So shame on him. All right, so Bill, what do you think here? Permutation, combination. You're asked to read 2 books from a list of 6. How many different ways could you get 2 books to choose to read?
Combination.
Yeah, why did you say combination?
Because it doesn't ask for a specific order of the books that you have to read.
Exactly, yeah. It's just saying pick 2 that you're going to read, but it doesn't say you have to read this one first and then that one second. So Bill, how would that combination get set up then?
6C2.
Yeah, and then if you don't mind, could you calculate that?
Yeah. $15.
Okay. So we could say what, 16 maybe pairs of books? Since it says how many different pairs of books. So we could have 15 different pairs of books to read. Nice explanation too, Bill. All right, so letter B. Jason, do you think you could read letter B and tell us what you think for letter B? All right, Josh, do you think you could read letter B and tell us what you're thinking for letter B?
12 students enter a talent show. Awards are given for first place through 5th place. And how many ways can the students finish 1st through 5th?
So what are you thinking for that one? Is order important, Josh?
Yeah, so
So-
I'm gonna say permutation.
Excellent. And the key words in there. Place, first through fifth place. So Josh, how many students are entering the talent show?
12.
How many different places are they going to get awards for?
First through fifth, so that'd be 5 places.
Excellent. Josh, do you have a calculator on you?
Yeah, I'm doing it right now.
Awesome, thank you. Nice job.
I got 95,040.
And we'll say ways to finish first through fifth place. All right, so Emma, how about letter C? For a 9-person baseball team, how many ways can you list the first 6 players in the batting order? What do you think for that one, Emma? Permutation or combination?
Permutation.
And how many players are on the team?
9.
And what number are we trying to get with the 9?
6 players.
Yeah, 6 players. So the first 6. Do you have a calculator with you, Emma?
Yeah, I got 60,480.
Nice job. And we'll just say batting orders. Boy, this is sloppy. Try and get a little neater here. All right, Mr. King, coming to you. How about that last one? What do you think? Can you read it for us, Mr. King?
I would love to. For a 10-person basketball team, how many ways can you select 4 players to take part in a pre-game coin toss? For that, it does not matter what order the pre-game captains are. So it'd be 10C4. 10C4. And then I put that in my calculator. That would be sorry, iPad is moving slowly. There we go. That would be 210. Pre-game captains.
Nice job, Mr. King.
Woohoo!
So how'd everybody do on those 4? Hopefully okay? Maybe you got them all correct, comparing permutations versus combinations. Are there questions? All right, so as I said, we were just doing a small handful of notes. I want you to go to Google Classroom. And we are going to pull up the worksheet for today, which is a begin to review for the test on Friday. So if you want to open up that worksheet, I just want to show you what it looks like, and then Mr. King will go over it with you. Make sure we got the right one here. Yeah. And notice if you scroll down, you're stopping at number 10. After that, there's more problems that we're going to use as like a warm up tomorrow, but you're doing 1 through 10 on this worksheet. So maybe remind yourself 1 through 10. And I'm going to stop my screen share so that Mr. King can pull up his.
You got it. Come on and load. There it is.
There you go.
So the first 3 are just using the fundamental counting principle. So there's not really a lot to do besides, I mean, you don't have to determine what's type. The next 6, 4 through 10, you're going to determine permutation or combination. So let's start with number 1, just to review on these counting principle ones, since it has been a little bit since we've done that. It says a pizza shop runs a special where you can buy a large pizza with 1 cheese, 1 meat, and 1 vegetable for $9. You have a choice of 4 cheeses, 9 vegetables, and 5 meats. Additionally, you have a choice of 2 crusts and 3 sauces. How many different variation pizzas are possible? So, Bill, what are different categories?
Cheese, vegetables, meat, crust, and sauce.
Good. So I put a C for cheese. I can even put a CH to make it a little easier to remember, so you don't get cheese and crust. Cheese, vegetable, meat, crust, and sauce. Very good. Bill, how many cheeses are there?
4,
Good. Just go right across. 4.
9, 5, 2,
Yep.
3.
Good. What we do is we multiply. And what is 4 times 9 times 5 times 2 times 3? You got it, Bill?
$1,080.
Yeah. So put 1,080 pizza variations. Questions on 1 through 3. Emma, Josh, Jason, have any questions on those? Okay, we're good. Numbers 4 through 10 are determining permutation and combination. I do want to do 4 with you because we haven't really looked at ones with a chart yet. It says Anne and her brother Will are ordering sundaes at an old-fashioned ice cream parlor. The ice cream parlor can make a sundae using any of the 6 toppings and 4 different types of ice cream, as shown in the menu below. Anne wants a sundae with 2 different toppings on 2 different types of ice cream. How many different choices of toppings for Anne's sundae are possible? So, in this case, it says she wants a sundae with 2 toppings on 2 different types of ice cream. So does it matter what order you put ice cream on, like your toppings on your ice cream?
No.
No. So we're going to start, it says 2 different types of toppings. So how many toppings are there?
Six.
6.
Yeah, there's 6. It doesn't matter which one we use, so we use C2. What is 6C2?
$15.
Good. So you get 15 here. And then it also says that she wants to have that on 2 different types of ice cream, correct? So how many ice cream choices are there?
4.
4, good. Does it matter which order you put your ice cream in?
No.
No, so we're going to go 4C2. And what do you get when you do 4C2?
6.
Good. So you get 6 ice cream. And then, oh, it didn't ask for both here, huh? I was doing what we're doing tomorrow. I read this wrong. They're only asking for toppings in this case. They're not asking for combinations with the ice cream. So we'll do this part tomorrow.
Actually, I think we have to do that for the next one, Mr. King.
Oh. But we're good with the toppings. You guys did that right. It says the second part says how many choices of toppings for ice cream are possible. So we got that, 15. Will wants a sundae with 3 different toppings on 3 different types of ice cream. How many different sundae choices are possible? So this one, we're going to combine both the toppings and the ice cream choices. So we'll do the toppings again. 6C, and then Will wants 3 toppings. What is 6C3? 6C3. That's hard to say. 6C3. What'd you guys get there?
20.
Yeah. So we have 20 toppings. Different toppings. And then he also wants, how many scoops of ice cream does he want? 3, right? So if he goes 4C3, what does that leave us with? How many combinations of ice cream could he have?
4.
4, good. And now we're going to use kind of combine this with our counting principle. What should we do with these 2 numbers to get our total? What do you guys think?
Think
Who has
about
an idea?
the counting principle. When you have these total choices, what do you do with the counting principle?
You guys know this.
So we have 20 choices of topping, 4 choices of ice cream. How many sundaes?
Multiply them.
There.
Yeah. We have toppings, ice cream, 20 times 4, and that'll give you 80. Yeah, so that one, and we're going to look at that more tomorrow. But are there questions on that? All right, let's do one more. Emma, why don't you pick one more we'll do together? Anyone on there? And I'll leave you guys on your own.
Do we still have to do number 5 for that one, or is that a different question?
No, that one's that's a separate question.
Okay, can we do that one?
So yeah, we definitely can. It says 5 desserts are arranged in order in a display. How many ways can the desserts be arranged? So does it matter when you're looking at display which desserts come second, third, fourth, fifth?
No.
Does order matter? No. Huh?
No.
Like which one's on the left, which one's on the right, which one's on the, not really, unless you're like tiering them up. But typically if you just bring out a dessert tray with a couple desserts, you just put them wherever and everybody will see them. So if order doesn't matter, we're going to use combination. There's 4 desserts. They're being displayed. And we want to show all of them. So 4C4. What would that give you?
1.
That came out with 1. Yep. Oh. Mr. King might have messed up on this one. Do you want order to matter here, Miss Kane?
Well, I mean, I guess it does say it's arranged in order, so. Yes, I guess so.
Emma, you were correct. Order does matter for which dessert goes first, second, third, fourth.
I guess
If
like
you
if
put
you're
it-
thinking you're going to like Eaton Park and looking at their dessert display, there is something on the left and then something on the right.
So that would be 24. And then this also goes into, which I'm glad this came up because if you ever get a question in statistics that just seems off, like for example, if you put the bigger number second instead of first and you get an error, if you think about all these logically, you can always do the counting principle on these, which is kind of how we started out with the 4 different dessert displays. Or if you went, there's 4 desserts, you put 1 there, then there's 3. You put 4, then 3, then 2, then 1. That's going to equal 24. Using the counting principle as well. Let's do one more because that was a bad one to end on. Josh, why don't you pick one more for us to do?
We'll do number 9.
Number 9, wonderful. A lock has 40 numbers on it, and the code to unlock it consists of 3 different numbers in a specific order. How many possible lock combinations are there? So, does order matter here, Josh?
Yeah.
Yeah. So if order matters, we're going to use combination or permutation.
Permutation.
Good. And then what would I put for the permutation?
It would be 40p3.
Good. 40p3. We pop that in the old calculator. $59,280. Is it 280? Yeah. And then Josh, what would you use for words for this one?
Would it be lock combinations?
Yeah. So you only need to go to number 10. We did 4 of them together. So you got 6 more. Please shout out if you have any questions. The rest of the time is yours. If you need to see anything at all, we'll be more than happy to go over any of these.
Yeah, and as Mr. King said, just to reiterate, stop at number 10. You don't have to do the next page whatsoever. We'll kind of go through those tomorrow. Not all of them, but some of them tomorrow. So stop at number 10.